6.7 task number 2 proofs. You need to prove that this rectangle is congruent in certain areas. So it says line segment AC, and remember that little symbol with the tilde over the equal sign means congruent, same size and shape as line BD. If you look at the rectangle, that is the leftmost vertical line of the triangle to the rightmost vertical line side of the triangle. We need to prove that they are congruent. We can say that they are, but it wants us to prove this using GeoGebra. I'm going to click into GeoGebra, and we're going to think about folding the rectangle like we have done in the past to make the line of symmetry. We're going to do that essentially with this picture here. So you need to do line, and we're making a line of reflection, which is going to be straight down the middle. That's where you would fold it if you were folding it to show symmetry. And then I'm going to do polygon, and I'm going to make a polygon just using that right side of the rectangle. So remember to do that. You click on each of the vertices and go all the way around. So if you start with G, you click around and you have to circle back to G at the end. Now we're gonna do reflective outline. Click in the middle of that polygon we just created until you can see it select, and then click on the line you want it to reflect over. And you can see it reflected onto the left side. There's no overlap. So now we can see that that line BD ended up perfectly on line AC. So we've proved it. I know this because reflecting rectangle ABCD over the line, we reflected it over that middle line, which is called GH. AC lands on BD. We just proved it. I also know this because I can rotate it around the center. How many degrees can we rotate it and show symmetry? You probably know the answer, but that isn't the point here. The point is that you prove it. Let's go into GeoGebra, and now we're gonna rotate this. We need to put a point at the center because when you show rotational symmetry on a shape, you rotate it around its own center. So that's the point there. And then we need to tell GeoGebra that this is the polygon. I'm going to do the polygon button and then click all the way around to get back to A to select that polygon. Now I want to rotate around the point. Rotate around point. Select object to rotate. Selecting the object, clicking on the rectangle, clicking on the dot in the middle. And I think that a rectangle has 180 degrees of symmetry. Well, you can try 90 to not prove it. So let's do that just for the sake of argument. So if I rotate it 90 degrees around that point, you can see, just like I do on the board with the shapes, 90 degrees creates that, and those shapes are not symmetric. The shape did not rotate around and land back onto itself. I'm gonna see if I can undo that step. Yep. So now, I'm not sure if my polygon is still saved there. I'm gonna trace it again just in case. All right, now I'm going to rotate around a point again. And I thought I maybe did that. I need to put my point there again. I need to redo my polygon one more time. A, C, D, B, A. Rotate around a point. I'm clicking on my shape in the middle of it. It selects. Now on the point, I want to rotate around. So if I do 180 this time, it doesn't matter if it's clockwise or counterclockwise when you're doing 180 degrees because it's a half turn basically, and it doesn't matter which direction you go, you're going to get the same thing. So you can see, because I see no overlap this time, it has rotated perfectly back on itself, a perfect 180. So going back to formative, I'm going to say I also know this because I can rotate rectangle ABCD around the center 180 degrees. Okay, last part, angle A. So if you look at where that pink letter A is, that angle there that has a little right angle square is the one we're talking about. It is congruent to angle C. That's the one, the angle right below it. I know this because, okay, which one of these could we do in GeoGebra? Reflect the rectangle over line GH. You might have to try some of these, but that seems to me like if I reflected it there, I'm not going to be comparing angles A and C. I'll be comparing different angles. So maybe not that choice. If I reflected over line EF, yeah, that could prove that they're the same. I'm going to try that. So back to GeoGebra. If I draw a line this time from here to here, and then I reflect the triangle hot dog way over that line, angle A should land perfectly on angle C. Let's draw the polygon. A, C, D, B, back to A. Now reflect about a line. Click the polygon, the line, and yeah, so it did reflect, but it doesn't look like anything because think about if you actually folded a rectangle hot dog style, that angle A there would land on angle C. And if you look closely, you can see that now where the original angle A was, there's a C prime. And we know that that means that that is where C reflected. That's the image. So it looks like we did it right. And now you can see where the angle C is, there's now an A prime there, which means it folded or reflected over that line, and A became A prime. So we've just proved it. That is our proof that those angles are the same. So I know this because by reflecting rectangle ABCD over the line EF, angle A lands on angle C. And angle A equals angle D, I know this because we can reflect it over GH. We did this already. If you need to see it one more time, back to GeoGebra, that was a line of reflection down the center, polygon, G, H, gonna click D, B, back to G, and then reflect about line, click the polygon, click the line, and it reflected over. So we have now proved that angle A is congruent to angle D. Ah, we didn't, because when we did that, well, I guess we could say when we folded it hamburger style or reflected it over line GH, angle D landed on angle C. But previously, we proved that angle A and angle C were congruent. Therefore, if D is congruent to C, it is also congruent to A. So I think, oh, here's some other choices. Now, I don't know if this one will work, but we could also rotate it 180 degrees. Reflecting it. So I think I'm going to choose that one and see if it will work for me. Yeah, it wants us to, instead of folding it across the center, they want us to rotate. By rotating it, the rectangle 100 degrees around the center, angle A lands on angle D. So that would be another way to do it, where you would have D land perfectly on A. I did it a different way, so that's going to get it to turn green. If you want to go back to GeoGebra and try that, you can. I'll just show you real quick. So we're going to go, we're going to rotate about the center point. There's the center point, polygon, A, C, D, B, back to A, rotate around point, select polygon, click on it, click on the point, and we're going 180. So now you can see that there is an A prime where angle D is, and there's a D prime where angle A is. So that proves that we rotated at 180 and that those angles landed on each other. That's another way to show it. Again, the way I showed it the first way was by proving that if you reflected the triangle over the middle, hamburger way, then A lands on C, and D lands on C, and we already proved that A and C were congruent. So I was showing that would be another method to show that they are congruent. This is the rotation method, which is what they want us to choose to make this number 2 turn green.